Okay, welcome. There seems to be a few people joining. Let me go ahead and get started. Welcome to the Hopsworks 3.0 webinar. I'm Fabio. I lead the engineering team here at Hopsworks, and today we're going to be talking about Hopsworks 3.0, the new release we just made, and in particular we're going to be focusing on the Python-centric approach of this new release. Before looking at the new release, I just want to kind of discuss a little bit why we believe feature stores are important and why we believe you need the Hopsworks feature store. So if you look at the general ecosystem out there and how people actually do machine learning, right? We can kind of split it into two categories, right? The one on the bottom left, what we call basically laptop ML. Essentially, people building up models on laptops, the models is only on laptops, based on some random CSV files, and it's all scattered around and unstructured. These like models don't really deliver business value, right? The business value gets delivered as a data scientist. You deliver business value when you actually put your model into production, whether it's an analytical model making prediction for the day after, all the way to operational models making real-time predictions, whether it's like a fraud detection system, whether it's a recommender system, making predictions in real time based on the latest available information for a user for some transactions and so on and so forth, right? To be able to actually deliver at that level, though, you need to have access to you need to have fast access to reliable data in a data scientist friendly way, to be able to actually use this data in a productive way. And what we see here is that there is a gap in between, like there's a jump between what we call as laptop ML and the first step of like really delivering business value, which is analytical ML. And that's where Hopsworks comes into the picture. That's where the Hopsworks Enterprise Feature Store comes into the picture, right? It's gives you access as a data scientist, gives you access to and what's probably the most valuable resources that you have within a company, which is all the data assets that you have, whether it's a data warehouse, whether it's data lakes, whether it's streams, whether it's a system of records, and so on and so forth. It bridges that with your work as a data scientist to create models, to make smart decisions, and to get eventually a competitive advantage over your competitor, right? So bridges the gap to your work to develop models, to productionize model, whether it's online, whether it's a batch one, and also building reporting system, building dashboards and reporting, right? So that's where it kind of sets out to be as a bridge between these two worlds, essentially, right? So the way it does it, and it brings together all the people in the team, whether it's data scientists, whether it's data engineers, whether it's machine learning engineers, or even business analysts, brings them together in a single platform to be able to create features, to be able to serve those features, to be able to govern those features, granting access to only certain people in certain teams, and ultimately be able to reuse the work that has been done already to build newer and better models, right? And it does that with a set of abstractions and set of concepts. We're going to be looking into some of them in Hopsworks 3.0. We have improved some of them. We have added some of them. So feature views is a new concept that we added in Hopsworks 3.0. And basically brings all this together, right? So if you look at the bigger pictures, we have all the enterprise data sources, again, applications, system of records, data lakes, data warehouses, streams coming in, being processed and creating features in the feature store. And all the way to the other side, we have what's the enterprise AI ecosystem, all the models being trained, being productionized, and all the reporting and dashboard being built by data scientists and so on, right? So everything is done through Hopsworks, and Hopsworks kind of make sure that the two worlds are actually bridged together, right? So that's what we believe. Like yeah, Hopsworks and the feature store is a key component of any enterprise AI initiative essentially out there. The focus of 3.0, and we're going to be looking into quite a lot in this session, is we made for 3.0 we made a big investment into being Python-centric, right? So what we believe is, and we're going to be discussing about it in details about it, is that Python-centric kind of raises the level of usability and being user-friendly for data scientists, allowing them to be more productive, faster, and ultimately building better models and productionize them faster as well, right? So there's been, funny enough, there's been quite a conversation going on the past couple of weeks between SQL versus Python. That's been going for years, right? So it's something that like Sark and Zarok actually summarized quite well. And it's kind of like what I believe is also the problem is that it's not a SQL necessarily is the wrong tool, but there are a category of things, and we're going to be discussing them today in this session, that Python does better, right? There is like a category of operations that are much easier to get done in Python rather than SQL. And we can look at a specific example right now, right? So when we look at the pipeline to productionize a model, the biggest part in terms of data management is feature engineering, right? So when we look at the entire ecosystem, again, we're going to be focusing for the next couple of slides only on the creation and management of these feature groups. So getting data from your enterprise AI ecosystems, creating features and storing them into Hopsworks. So when we talk about feature engineering pipelines, what we do here at Hopsworks is actually we break them down into two different phases, right? We break it down in the feature pipeline that actually creates features and write them in the feature store, and we break it down from the transformation pipeline that actually applies some transformations like normalization and one-hot encoding when you actually need to use the features. And I'm going to come back to this aspect and why it's important to split these two later on in the presentation. And for the moment, they're going to be focusing on the left side, which is the features pipeline, right? So there are a couple of different things you can do to create features, right, at the higher level, right? So you can do stuff like aggregations, whether it's just a simple group by, whether it's a window aggregations. You can do dimensionality reduction, right? The most popular one is probably embeddings. And also you can do data validation, so making sure that the data that lands in the feature store is clean and higher quality, and you don't have the problem of like garbage in, garbage out when it comes to features in the feature store, right? And if you look at the ecosystem of tools that are available out there, for aggregations, there's quite a variety of features of tools that you can use. You can use SQL, you can use Spark, right? PySpark on Scala, and you can use Python and Pandas data frame, right? When it comes to the dimensionality reductions, there are a lot of libraries, but most of them are probably all of them are only available as a Python. The most popular one, and I have an example later on, it's transformer library from Hugging Face, right? So that's a Python bindings. You can use it from Python, and you basically compute embeddings from there. And finally, validations. There are a bunch of tools out there. Popular one again is, and used a lot by data scientists, is actually Great Expectations, which is actually available as a Python library. And on the other side, again, if we look at the transformation side of things, right? We have stuff like normalization, stuff like one-hot encoding. All the major frameworks out there, like whether it's scikit-learn, whether it's TensorFlow, with PyTorch, they offer some sort of support for doing this type of operations, and then all of them again they are Python first, Python-centric APIs basically, right? So mostly at that stage is just Python operations. That being said, right, when we talking with customers and users, what we've noticed is that even for aggregations, from our experience, most of the scientists actually just prefer to use Pandas. If we really have to, they go to Spark or SQL. But if the data is small enough, they just use Pandas to do the operation they need to do. and they are more familiar with that, right? So from our perspective, and that's where the investment we made. Hopsworks has always had support for Pandas and Python, but with Hopsworks 3.0, we really want to make sure that it's really user friendly and really responsive, and making sure that like data scientists have a great time building features and using Hopsworks directly from Pandas and Python, right? So that's the investment made in 3.0, and let me a little bit show you like how that works in practice, right? So this is an example of like computing some aggregations in Panda and creating a feature group out of it, right? So again, we have a couple of lines where we do some operations with the Pandas data frame. We merge it with an existing bigger Pandas data frame, and that Pandas data frame is my feature group, right? So all the columns that are in Pandas data frame, they get actually created as features and registered as features in the feature store, right? So that's what happens at line 10, right? So I can call get to create feature group. I give the name, description, a version. I'm gonna decide. I'm gonna tell Hopsworks which of the columns is gonna be used as a primary key, right? To identify the particular column that identifies the features, right? I have event time to determine like each transaction. In this case, we are handling fraud at each transaction as event time. I'm going to mark that as a special feature, a special column in the feature store. And at line 19, everything I have to do to be able to write that is basically called insert method, provide the Pandas data frame, and yeah, it's going to be registered with the feature store immediately. This is a snippet of code I got from the tutorial that we have made available with Hopsworks 3.0, and I'm going to just walk through the tutorial complete in just 1 second. This is another example on how you can do feature engineering. This is the dimensionality reductions. Here we are computing some embeddings. We're using a library from Hugging Face, the transformer library. Just compute some of the embeddings and register those embeddings into the feature store in the same way, right? So again, we operate over the books data frame, and we're gonna like register that as features in the feature store. The last steps that we have in like the feature pipeline is validations, right? So what you want in the feature store is making sure that everything that's in the feature store is actually high quality data, right? And to do that, you need to set some quality control and gatekeep some of the data that comes into the pipeline. To do that, like since Hopsworks 2.0, we had support for data validation. That was done using a library called DQ. But that wasn't really Python friendly, right? We didn't like it required Spark to run, and it was a little bit cumbersome to actually use. So in Hopsworks 3.0, we had the first class support for library Great Expectations, right? So it's a popular library. It works out of the box into Hopsworks, and it's transparent for the user essentially, right? Let me show you how you can use it, right? So you can create an expectation suite. So essentially, that's what Great Expectation calls a set of expectations. That's all defined as Great Expectation suite. So if you already have an expectation suite defined for an existing pipeline and you are migrating that to Hopsworks, you can bring the expectation suite directly into Hopsworks as it is. We don't have to change anything, right? So the only thing you have to do is, if you see a line 24, when you create the feature group, you will say, okay, this is my expectation suite. And what Hopsworks is going to do every time you call insert is going to actually run the expectation suite and making sure that that is correct. So when it comes to line 28, automatically when you get a new data frame coming in, Hopsworks validates that data frame using Great Expectations, and if it's correct, then it's gonna keep writing the data frame into the feature group. Otherwise, it's gonna trigger a notification, whether it's email or Slack. That's the supported notification that Hopsworks provides. And again, Python-centric doesn't mean you can't use any other tools. you can still use SQL, and you can still plug Hopsworks with your existing data warehouses that you have. You might have like a Snowflake, Redshift, or data on S3, and so on. So all these capabilities are still available. You can still run PySpark pipelines. All of this can still happen. Obviously, 3.0 just put particular focus on making sure the Python experience is top notch. Okay, so we talk about how to create features. Let's talk a little bit about the how to actually use those features, right? So in Hopsworks 3.0, we actually introduced a new abstraction called feature views. Prior to 3.0, we had this abstraction called train data set, but like we were working with like different users and customers, and we've seen how the train data set abstraction didn't really live up to the expectation, didn't really allow data scientists to use it easily. So we went back to the drawing board, and we said, okay, how can we make the experience better here? And that's kind of where feature views came into the picture, right? So let me talk a little bit let me show you a little bit how you can actually use it, and talk you through like the capabilities that it has, right? So the basic idea of feature view is that it's a container of features that your model need for training, for serving, and so on, right? So what you do to create a feature view is essentially you select a bunch of features from many feature views, many feature groups. You basically, that's what happens in line 6 to 9 essentially, right? You're selecting features from different feature groups with an API that like it's really similar to the Pandas API. So data scientists are really familiar with that. They don't have to learn a new syntax. It's pretty much the same, and they can have an expectation of like how the APIs work essentially, right? So you define a set of features that you want and how to join them together, and you create that feature view, right? So you see line 11 that we proceed with the creation. We give it a name. We create a query. We mark one of those features as a label, right? And also we define transformation functions, right? So here, this is what I was mentioning before. What like we separate the pipeline, the feature pipeline from transformation pipeline, because that allows us to reuse features more easily, right? So think about this, right? You might have a set of features used by a couple of different models, but a model might be using a subset only of the US customers. Another model might use the Europe customers, or like you have a model looking at 5 years of history, and another model looking at only the last 12 months of history, and so on and so forth. Like by putting normalizations after, right, each model can normalize data depending on the underlying data itself, right? So if you're doing if you are normalizing using the min-max scaler, the normalization will happen only on the cut of data that you're actually using for only on the split of data that you're actually using for that specific for training that specific model, right? So when you create a feature view, again, you set which transformation you want to apply to which features, right? And we have a set of them, that transformation functions that are available already out of the box. And we have you can also define your own using our API, and you can find all more details on that in the documentation. What's interesting here is that if you go back to line 6 to 9, where we actually select the features and join them together, this is not just a simple join. Here we are also enforcing behind the scenes on behalf of the user point in time correctness. So when you're joining features from different feature groups, you want to make sure that when you join them together, you're not leaking data. Essentially, you're not joining the event from today with the event from tomorrow, because that's data leakage, and that causes problem with the model. So what this like 4 lines of code actually turns out to be behind the scenes is the Hopsworks is going to transpile that Pandas join into this horrendous SQL query that it's cumbersome to write, and it's error prone to write for anybody. And what this does behind the scenes is going to go to different data sources that you have, different feature groups, whether you might have data on Snowflake, join data with some data on Hopsworks, and so on and so forth, and join them together, making sure they are aligned, and making sure that you have applied any different filtering and so on and so forth. All this gets all transpiled into SQL and executed on your behalf, essentially, right? So from a data science perspective, you don't have to worry about this generating this query. You have to select which features you want, and Hopsworks is going to take care of the rest of selecting the proper features in the correct way, essentially. And finally, again, the feature views, and I mentioned briefly already, it's what I like to call like one API to rule them all. It's essentially a container that allows data scientists to do different things, right? Allows data scientists to train a model, right? So you basically select a bunch of features, you apply transformation functions, you generate a training split to say, okay, these are going to train the model on this specific split, right? This specific split has some structure, has some statistics, and those statistics are registered back into Hopsworks, right? And they're going to be used, and they're going to be useful when you're actually going to serve that model, right? So when you the day after, the month after, the 6 months after, where you're going to every day score that batch model, you're going to get like fresh new data coming in. You're going to apply a transformation function for that feature view. You're going to be looking up the statistics that you have trained the model on. You're going to apply the normalization, the label encoding, or any other transformation function you have applied, and you're going to get back the correct batch of data that you need to score. And the same thing happens when you're doing real-time predictions, right? So you are basically asking in this case, the online feature store for feature vectors. Okay, these are the features you need, and this is the transformation function you need, and these are statistics, and you basically the feature view API will take care of for you of applying everything together and making sure that the results at the end is what you need to provide to the model. So the vector of normalized features in the correct order to feed to the model for actual predictions. Finally, Hopsworks is an enterprise platform, right? So there's also like a lot of focus going into making sure that enterprises can use Hopsworks to manage those features in a secure way, and granting access only to the people that actually need access, right? So all the platform provides access to, for instance, stuff like lineage, access control, provenance, and so on and so forth. Allows you to control who has access to certain features, but also allows you to reuse some of the features that you have already created in potentially many different models, right? And I mentioned before, we can see it in a second in a quick demo. The features are organized into projects, and you can use features from different projects to actually build out the feature view, and you can grant access to projects to different teams and people, and making sure that they are they can collaborate with each other, or they need to, if they need isolation, they are isolated from each other. Finally, if you like what you've seen, with Hopsworks 3.0, we also released a serverless platform, right? So it's an Hopsworks 3.0 deployment where you can just register and start building cool things on it, without worry about deploying the platform, without worry about connecting your AWS account or anything like this. The platform is completely serverless. You just have to register, and I'm going to show you in a second how to get started with it. And yeah, you have plenty of quota. It's not time bound. You can just get on and start building cool models and cool prediction services on it. So if you want to get started, it's actually quite easy. Let me show you. You go to, let me just jump to the screen. You go to Hopsworks API. Hopsworks, let me type it correctly. Yeah. And you can click on Start Now for free. It leads you to Hopsworks API. I'm already logged in. Otherwise, you will be asked to actually register with the platform. You're gonna get a project, but you can also get a bunch of different tutorials to get started with. The easiest way to get started is using the Quick Start notebook. It's a Colab notebook that I have already opened. And this notebook goes through the fraud demo that I took this snippet of code from, and allows you to create feature groups and so on and so forth, right? So let me go back for a second to Hopsworks. you can go click on go to Hopsworks, and this brings you to your project that is personal to you, right? So you can see all the different feature groups that the tutorial has created. And you can go back and forth. You can basically see, you go through the, I'm not going to run this notebook, but because I've just run it. But if you go through the tutorial, it's going to do the feature engineering part. This is the section of the code I had in the slides before. It's going to create different the different feature groups that are needed. It's going to select the features to actually create the feature view that you have here. It's going to set the transformation functions for all the features that are needed. It's going to create the feature view, and it's going to go on and train a model with them. And it's going to also register. In this case, it's actually going to register the model with Hopsworks. It's going to deploy the model, and it's going to start making inference requests directly with the model, right? So if you run to this notebook, you should end up with these feature groups and that are available. So if you start exploring them, you can see that you have a list of all the features. You have access to provenance, so figure out where those features are actually being used in. This is the what I was mentioning before about great expectations. So here you can basically see I added expectation. I started writing some bad data. The write was stopped because it didn't comply with the underlying data. So the write was actually rejected. You can attach any number of tags that you want, and you can also, in case of the unsuccessful execution, you can decide to send an alert. Essentially, you have access to all the features like statistics, so you can see both descriptive statistics and like distribution, both for numerical features but also for categorical features, and those are available. You can have a look at the also the correlations between different features, right? So looking at how the features within a feature group actually correlate with each other. You can also have a look at the like a snapshot of the data, right? So if you want to have a feeling of how data looks like, and so on and so forth, all of this is available through the UI essentially. Everything is searchable, right? So if you're searching for, I'm not sure. Let's see. Let me see. Search for this one. Just making sure. You can find different feature groups that contain your features. You can find the actual features that contains that is defined. So you can search for names, you can search for descriptions, and everything like this, right? And ultimately, then you're going to create the feature views. That's what the notebook is going to do. It's going to create for you a feature view. It's going to create for you a train data. So again, here we have all the list of features that are being used, which transformation function have been applied to, and here it's the actual training data set. So from the training data set, you can figure out the statistics that are going to be used for those transformation functions, especially when it comes to normalization, right? So all the statistics going to be stored here, and they're available through the UI and also through the API, and they're going to be used for actually this is the bit that we're looking at, and they're going to be used for creating for normalizing data and so on. And finally, the notebook is going to create a model for you. It's going to register that model, and it's gonna actually create a deployment, so you can basically make inference requests online directly from the notebook itself, right? So when you call predict, it's actually going to send a request to Hopsworks, and it's going to actually look at it. We're going to be talking a little bit more about the model registry, the deployment in a separate webinar. But that's how the quick start notebook works, and you're going to make requests in real time to the model being served on KFserve. Yeah, so all this is available for you. You can just register in, jump in, and start building. And that's everything I have for you today. Thank you very much for joining. If you have any question, let me know, and I'll take your questions now. Let me stop share.